Bismillahirrahmanirrahim. Assalamu alaikum. This is the part 2 of getting started with ALTERA DE2-115 Kit. What you will learn from this tutorial: creating a new project in Quartus Prime Lite, creating a Verilog file in which you will learn how to control the push button, how to get its commands, and how to control the LEDs according to the program. In the last, we will assign pins to buttons and LEDs and upload the program on DE2-115 Kit and test the hardware. Moving towards the part 1, creating a new project in Quartus Prime Lite. Go to Windows tab and write Quartus Prime Lite. Hit enter. Click on the new project wizard that comes under the Home tab. Click Next. Locate the directory on which you are planning to work. I'm working on a D drive. Write the project name. Project button and LEDs. Click Next. Select the empty project. Click Next. Click the correct version of Cyclone. It is mentioned on the kit DE2-115, that is Cyclone 4 E version. The package is FPGA, pin count is 780, core speed is 7. And among the options which are shown below, the second last option is the one whose chip is placed on the DE2-115 kit. Click Next. For simulation, I'm using Questa Intel FPGA. For design entry, click on this thing. Click Next. Hit Finish. Your project is created. Creating a Verilog file in which we will use push button and LEDs. Push button is to control the modes and accordingly controlling 3 LEDs. Now we will create a new file of Verilog HDL. Click OK. Here we will write a module that will incorporate the buttons and LEDs. I have created a file for you and I will explain each line one by one. First of all, the module should be named as the name of your project. Module project button LEDs. We have 3 inputs in this program. One input is the clock signal. Obviously, we are tracking the inputs, so we need a clock. And the other input is a reset button to reset the program. And the other input is the push button, also a push button. Basically, this program is about to changing the modes, mode 0, 1, and 2, using a push button. And by the changing mode, we will control the 3 LEDs. The output is 3 LEDs from 0 to 2. In this block of code, I have implemented the debounce logic of button and its states to be read properly. There's a register of 20 bytes declared for debounce counting, some register declared for the byte synchronization in stable states and previous states. This all logic is for the debouncing a button and detecting a proper press of a button. Here, if the reset button is pressed, all the registers that are declared here will be reset. Note that State 1 means the button is in its reset state or initial state. If the button is pressed, then the logic will be 0. If the reset button is not pressed, the normal operation of debouncing and detecting a button state will be executing. There's a 20 millisecond debounce implemented, and here a proper button pressed is stored in the button pressed. Now there's a time to declare the state machines, tracking a mode, and on the basis of mode, we will be turning the LEDs accordingly. And here we are. If the reset button is pressed, then mode reset to 2, and if not, the mode increases. And here is the LED code in which, according to the case of mode, if the mode is 0, 1, or 2, the LEDs will glow. This combination, you can see 001 means LED 1 will glow, LED 2 will glow, LED 3 will glow, accordingly to the modes. So this was the complete file of project button LEDs, a Verilog file, and let's compile it, pressing Ctrl and L key. The code is now compiling. If we see the ticks on the left side, that means the code compiles perfectly. Now the code is compiled and no issues are there. Pin assignment, program uploading and testing the hardware. Now click on the assignments and hit pin and pin planner. For the button and the pin, go to this and type pin underscore M21. And basically M21 is the push button to control the LEDs. And you'll now set the reset button pin. And by the way, the button M21 is the button number 2 of push button. The number first push button, I'm setting it to that. And for the first push button, we'll assign reset to that. Pin underscore M23. Now moving towards the LEDs, these are pin E21 for LED number 2, pin underscore E22 for LED number 3, pin underscore E25. These are green LEDs above the push button, and for the clock we have this one, Y2. Pin underscore Y2. All pin assignments are done. Now it's time to compile that again. After pin assignment, Control L to compile. Everything is okay. No issues in compiling. All checks on the left side. Now it's time to program the board. Go to Tools and click on Programmer. Make sure your board is connected to your laptop or PC to the first port that is mentioned as a USB blaster under beneath it, and make sure you have a proper driver installed, and then click on Start to program the board. As you can see, there's a light indication for programming. Board successfully programmed. Click cross. Now see towards this LED. You can see this one is the reset button, and that's the push button to control the modes. Hit enter. Mode number 2, mode number 3, mode 1, mode 2, mode 3. And if I press the reset button, program resets, and a mode is shifted towards mode 1. Mode 2 selected. Pressing this will initialize the program again. So this was the complete demo of how you can control your LEDs output according to your program, how to get the input from the buttons, and according to the inputs, you do some calculations, you do some mathematical calculations or logical calculations, maybe if else loop. So that was it, in which you learned how to use the buttons and control the LEDs. Thank you.